Theorem 6.2 and Theorem 6.3. Can we use the corresponding angles axiom to find out the relationship between alternate interior angles when a transversal intersect two parallel lines? Let's see. So in the figure, the transversal PS intersects the parallel lines AB and CD at Q and R. So we already know that AB and CD are parallel and the transversal is intersecting them at two distinct points. What we need to prove is angle BQR equal to angle QRC? So this is angle BQR. Is it equal to angle QRC here? Are these two alternate interior angles equal? And angle AQR is equal to angle QRD. So that's what we need to prove. You know that angle PQA, that is this angle, is equal to angle QRC. Why? Because corresponding angles axiom states that when two lines are parallel, then the corresponding angles are equal. So these two are equal. Is angle PQA, that is again this angle, also equal to angle BQR, that is this angle? Is this also equal to BQR? Yes. And why? Because they both are vertically opposite angles. So looking at 1 and 2, you can see that PQA is equal to QRC and also PQA is equal to BQR. So according to Euclid's axiom 1, we know that if things are equal to the same thing, then they are equal to each other. So we can say that QRC is equal to BQR. So these two angles are also equal. So we can conclude that BQR is equal to QRC. And thus we proved that one pair of alternate interior angles are equal. Similarly, we can prove that the other pair AQR is equal to QRD. So theorem 6.2 says that if a transversal intersects two parallel lines, then each pair of alternate interior angle is equal. Now, let us look at the converse of the theorem. If a transversal intersects two lines such that a pair of alternate interior angle is equal, then the two lines are parallel. So we are given a pair of alternate interior angles which is equal, and then we need to prove that the two lines are parallel. So in the figure, the transversal PS intersects line AB and CD at Q and R. So we have two lines. We don't know if they are parallel or not. We just have two lines and a transversal which is intersecting at Q and R such that angle BQR, that means this angle, is equal to angle QRC, this angle. So this angle and this angle are equal. That's all we know. It's given in the statement. We need to prove this. Is AB parallel to CD? Is these two lines parallel? Let's check it out. Now we know that BQR is equal to PQA. So if you look at PQA, is it equal to BQR? Are these two angles equal? Yes, because they are vertically opposite angles. Also, BQR is also equal to QRC, which is already given in the question that BQR is equal to QRC. It's stated here. So now we can see that BQR is equal to PQA and BQR is also equal to QRC. Again, with the help of axiom 1, we know that things that are equal to the same thing are equal to one another. So we can say that PQA is equal to QRC. So from 1 and 2, you may conclude that angle PQA is equal to QRC. But PQA and QRC are corresponding angles. But they are corresponding angles. And so if you remember the converse of corresponding angles axiom, we know that when two corresponding angles are equal, the lines are parallel. And so we can say that AB is parallel to CD. So the two theorems studied in this video are Theorem 6.2. If a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. And the converse of this theorem is Theorem 6.3, which says that if a transversal intersects two lines such that a pair of alternate interior angle is equal, then the two lines are parallel. Both of them are true, and we have proved it here, and therefore they are called theorems.